right. Well, good afternoon, folks. This is Richard Massey with Civil Plus Structural Engineer, and I'm talking with the esteemed Charles Copeland, who is co-founder of Goldman Copeland Consulting Engineers in New York City. That was a mouthful. How you doing today, Mr. Copeland?
Good. I'm good. I'm looking forward to talking about these issues with you.
Yeah, great. Well, let's go ahead and jump right off into this. You know, that Con Edison power outage was obviously made national news, it being New York City and, you know, the financial capital of the world. And so what happened with the Con Edison power outage?
Right. Well, it's obviously a very complex system in New York. It all runs underground. There's lots of circuits and there's lots of connections throughout. Clearly a lot more reliable than if it was outside of New York City and could get, toppled by trees in a storm or whatever. But still, it's quite a complex system, and it's going to have its challenges. It's an older system. Not all of it's the utility fault, but these kinds of things are going to happen. As you know, most of the electricity that we all get comes from remote places. For example, most of the electricity New York gets either from a fossil fuel plant, or it gets about 25% of its electricity from a nuclear plant.
Oh, okay.
Indian Point, which will be shut down in a couple of years for a number of reasons. Most importantly, it's probably at the end of its lifetime.
Mm-hmm.
As much as we like the idea of it being low in carbon, since it doesn't burn any fossil fuels, on the other hand, it is pretty much getting to the point, I guess, probably close to 40 or 50 years old, where it needs to be eventually shut down. So that big plant will be shut down, supplying 25% of our electricity, and so even more of it's going to come from fossil fuels. If I talk a little bit about New York City, as you may or may not know, has recently developed one of the most stringent codes or legislation regarding the use of energy in buildings. And I think it's likely the strongest in the country right now. And in a few years, there will be significant fines for buildings that exceed that amount of energy use. So I guess the goal is in the future is to figure out ways to use more electricity, but electricity that's generated by wind or solar,
Mm-hmm.
et cetera. I think that's, in my view, it's a ways off before we get to that point. And my suggestion is that we think more about some intermediate steps, one of which is cogeneration.
Right.
Which, as you indicated, is kind of the microgrids. And there are a lot of, significant housing developments, affordable housing developments, the largest in Manhattan being Penn South, a large one, Rochdale Village in Queens.
In Jamaica, yeah.
And also Co-op City, interestingly, was going to be all co-generated when it was built in the late 60s and early 70s. And the utility came to them in those days and didn't want to lose this huge customer. I think it's one of the largest developments in the world. So they made them a special deal so they wouldn't go to cogen.
Oh, okay.
Come off the grid. However, within the past 5 to 8 years, they have gone back to putting in a cogen plant and using the waste heat. What I like to explain to folks that when you generate electricity remotely, a very limited amount comes to the end user. So typically, approximately 34-35% comes to the local user, and most of it is either exhausted in the atmosphere remotely, or it's lost in transmission lines. And usually I show some of my staff and other folks a little graph I have on the wall, which I'll show you, which is published by federal government, and it shows basically this is the energy that goes in across the country, and most of it gets lost in conversion losses.
Okay, okay.
Then further, there's transmission losses, etc. And so you're left with this relatively small amount of the total energy that went into the plant. And what these other developments like Penn South and Rochdale do, instead of discharging that waste heat into the air, that waste heat is captured, and usually it goes to heat domestic water.
Okay, okay.
A residential complex is a big user of energy, so the waste heat doesn't get evaporated into the air; it goes into the heat to water. So typically, in that kind of a situation, you almost double the useful energy out of the fossil fuel. So instead of being 32, 34% or whatever, it's jumping up to 65. So people like me think that this is a good interim measure until one day we are completely wind or solar.
Okay.
But that's pretty much the way it works.
Well, how are these cogeneration plants, how are they fueled? Is it natural gas or?
Typically, some of them are complete natural gas. For example, microturbines. We've designed a number of microturbine installations. They're strictly natural gas. The plant at Penn South is a mixture of natural gas and oil.
Oh, wow. Okay, okay.
And it has to do with, as I understand it, the plant is pretty old, but has to do with synchronization, and the operators have to have a certain amount of the generation on oil, so that it better synchronizes apparently than natural gas. I'm not an expert on it, but that's what
Right. And what about Rochdale? How's that one fired?
I think that's not 100% sure, but I'm pretty sure that's might be all gas, but I'd have to check it.
Right, and so I think it's significant, and one of the reasons why we're talking, I thought it was really neat that you had these big rolling blackouts in New York City, but Rochdale and Penn South did not black out.
Right.
Because
right.
They're not on the New York City grid.
Exactly.
But, doing my research, Penn South is 3,000 units.
Yep.
So, 3 people a unit, that's 10,000 people.
Yep.
And then Rochdale is 20 buildings. So, let's talk about these cogeneration power plants. It seems like they're custom built for these big, large housing units like the 2 that you mentioned.
Yep. In the case of Penn South, that was retrofitted well after it was built. It was built in the early 60s. And actually, there's a wonderful picture of John F. Kennedy being at the opening of Penn South and congratulating everybody for getting this sort of middle income or affordable housing complex built. In the case of Rochdale, I believe that plant went in when it was built, as
Okay, right.
as Co-op City would have been, but Penn South was retrofitted in the 80s. So it's complicated to do that, but they did it. They got it done.
Well, they used to do difficult things back in the Kennedy administration.
There you go.
But that's a different conversation.
Yeah,
Don't
exactly.
do something because it's easy. Do it because it's tough and difficult to do. But
Now, let's get on the moon.
yeah, right. Yeah, and but that's kind of interesting. So that, but if these things, if Kennedy was at one of the groundbreakings for one of these, then this technology is not really new.
No, we've had generators for decades, obviously, way back, to generate electricity. But using the waste heat and using it in a resourceful way hasn't been that much done until probably the last 20 or 25 years. So, and as a matter of fact, I was oversaw the installation of the largest commercial building installation that's operating now right near our office here. It's at 110 Plaza, a very large complex, probably in the neighborhood of 2 million square feet or something. And they have a very interesting installation which generates high pressure steam as well. So the waste heat that's discharged into the air, they use a heat exchanger to recapture the heat from it, and they generate high pressure steam, which is used in the complex to run their turbines, steam turbines.
Okay.
And when they have excess, and to heat the building, obviously, in the winter. And in the, clearly, sometimes when they have excess, they have an arrangement with Con Edison to discharge the excess steam into the grid.
Oh, okay.
And just to give you a little sense, New York, Manhattan has the largest central steam distribution in the world.
Oh, okay.
Yep. So it's all underground steam. And most people think, well, maybe it's not that efficient, but actually some years ago, 10 plus years ago, Con Edison put a cogen plant in. And they put a cogen plant on 14th Street. So most of the steam that comes underneath the ground is co-generated, which means they are generating electricity, and the waste heat is distributed to all the buildings for heating and cooling. So sometimes in the summer when the demand is less, the amount of steam we're getting is probably in the 65% co-generated range. So in other words, 65% of the steam is co-generated. So these are all good interim measures before we actually get someday, hopefully, to wind and solar. Having a cogeneration system is good measures going forward.
Right. So you see this as a good transitional technology from fossil fuels to the true advent of large-scale renewables.
Yeah, we're all hoping that for our grandchildren and their grandchildren.
Well, and that's the thing, with New York City, it's so big. There's so many people there. It's such an important city that garners so much attention. It seems like that's a great laboratory to figure out what this technology can really do.
Yes.
When you've got thousands and thousands of people that are relying on it every day.
Absolutely.
Well, now, and what's your involvement and your firm's involvement with this whole cogeneration movement and pulling things off the fossil fuel grid and getting them into a more sustainable electricity delivery system.
Yeah. So we've developed or designed a number of systems. It's unusual to have a situation where you have cogeneration for the entire complex. So typically, cogeneration involves, some portion of a building. So, for example, we've designed a number of capstone type microturbines. I shouldn't use a brand name, but a microturbine installation. And those typically generate electricity, and then the waste heat is used for heating, or they're usually smaller systems, so might be used for domestic water. So there's a number of those that we've designed. Also, one of the earliest large installations, as a matter of fact, speaking of New York as being a laboratory, the fire department in New York is pretty rigorous about the requirements for, for installing things like microturbines, and they weren't allowed to be installed until we did the first one. I think it was 1350 Avenue of the Americas. And we went through the whole process with the fire department, made sure we had all the safeties built in because it used high pressure gas, which obviously we're all concerned about. And it was the first one of that type to be installed, and they actually wrote a section of the code based on the requirements that we designed, that we included in that. So
okay,
we are advocates, we're consultants to a big affordable income housing going up on the Upper East Side, or that's installed already, but this is going to be a retrofit. So we are consultants, but obviously until a client wants to commit the funds to do it or make an arrangement. And as a matter of fact, there are folks out there that will put the whole system in, and the ownership, they'll pay for it, and they'll give ownership a percentage of the savings, which is what's happening on this large project 1199 on the Upper East Side. Ownership gets a percentage of the future savings. They don't have to spend any money, and they move forward that way. Obviously, we are not a vendor or anything. We're engineers, so we get called in to review it or to oversee it. Fine, but we're not involved in the actual committing of an arrangement with an owner that wants to do it. But
okay, right.
Yeah, we strongly encourage folks, and many other commercial buildings also have cogeneration for part of their loads. There's a couple of them up here near us on 42nd Street, newer buildings. It's a little more challenging to do it on older buildings.
Sure.
But I believe most newer buildings are incorporating some form of cogen, or even what we're seeing is battery storage. So, we're seeing in some cases lithium batteries being used to store electricity, so that it's stored off peak and it can shed some of the load on peak. Generating electricity from the utilities perspective on a peak day is often very inefficient, because they often have to use, gas turbines that aren't very efficient, that just pump out some electricity just to meet the peak demand. So those aren't a great solution. So folks are happy to have someone taking the energy off peak, if you know what I mean.
Sure. Well, fascinating. But I want to back up to something I think is really interesting, Charles, that you spoke of earlier, is that New York gets 25% of its power from a nuclear power plant that's about to be decommissioned.
Exactly.
I mean, and higher environmental regulations passed by the legislature.
Right.
But fossil fuels still power much of the city. So to me, it sounds like there's a collision course coming up here sometime soon. They don't even have a proper place to store spent nuclear fuels either. I mean,
Absolutely.
they haven't built that facility yet. So it's kind of a mess. But what happens to New York City 5-6 years down the line when, something needs to happen? Or are they going to be ready?
Well, they're struggling, and we've been on some of the committees with the city, with the mayor's office, on the new regulations to reduce use of electric energy. I tell folks that when I started in the business, the lighting accounted for like 2.25 to 2.5 watts a square foot. Now, by code, you can't use more than 1 watt a square foot for lighting.
Okay.
And even going forward, even less. It certainly is a challenge. Some of these new regulations don't kick in for, maybe 4 or 5 years. I honestly don't know what's going to happen. We're all struggling. Some of the real estate people are not too happy because these regulations will create fines.
Oh, right, yeah.
And these fines will be passed on to the tenants. And some folks think, well, that's going to put New York at a disadvantage by being so concerned with energy that, they're going to charge the tenants even more. So we'll have to see. But clearly, there's lots of challenges, but we have to do something, obviously.
Sure. So you're a big proponent of getting off that fossil fuel grid and, going back to earlier in our conversation about doing something because it's difficult, getting to the moon, is our country going to, and lead construction's only 30% of the construction industry. It's made leaps and bounds, but it's still the minority in sustainable construction total. Are we ever really going to get there?
Well, I sure hope so. I got 8 grandchildren, so I'm hoping that we get there.
Sure. Well, Charles, and in the meantime, before we completely get there, you're a proponent of these cogeneration plants where you're delivering more back end, you're delivering more to the back end user, and you're collecting that waste, and
yes,
you're not losing a lot.
We're doubling the efficiency of the remote fossil fuel electricity plants by doing cogeneration locally.
Right, and a good jumping off point was to look at that Edison power outage back in July that
Exactly.
kind of proved the resiliency and the importance of these cogenerational plants in the largest city in the United States.
Exactly.
Well, great. Well, Charles, I know it's a short conversation, but wow, you're brilliant, and I know you've been up there in New York City for a long time. Congratulations on being named a legacy engineer by ENR. That's a pretty big honor.
Right.
Yeah.
I spent some time in the Midwest too. So.
Oh, okay. Well, I appreciate your time, and look for us out on the web. We'll have this posted here, hopefully sometime in the very near future. And I appreciate you taking the time to speak with me.
Thank you so much.
Thank
you have a good day.
All right. Bye-bye.